Then a very warm morning, I hope, at least for most, to our very first EVERSE webinar. I'm very happy to see that we have quite some attendance already. My name is Sanja. I will be one of the moderators of this day, and we have a structure today of 2 talks, around 20 minutes each, and then we'll give the floor to you. And to start off, I will first hand over to our work package leader from work package 1 on the network, to Graham Stewart.
Okay, thanks very much, Sanja. So again, let me extend my welcome to you to this first ever EVERSE webinar that we're having. We had the launch event for the EVERSE network way back in February. It seems like a long time ago now. And there was clearly a big interest from people to establish a place where people who were interested in research software quality from Europe and the rest of the world could get together and talk about some of the important topics which we need to do to improve research software quality. So this is the idea of the webinar series. We want to tackle a whole range of topics, so things like aspects of research software quality, some of the outputs from EVERSE that we are generating, which is the topic of today's seminar, but also presentations from the science clusters or technical topics that you think are interesting or important. And I would again stress here that any ideas that you might have for topics that we could cover in EVERSE webinars, we'd be delighted to hear from you. Just get in touch with us as the organisers, and we'll discuss and see whether we can slot it in. So let me just say a few words about the first meeting that we have today. We're going to be looking at the landscape of software quality and defining software quality indicators. This is a very important part of framing the whole discussion about software quality. And we're very lucky to have our colleagues Jutta and Daniel, who are going to tell us about the work, some of the work which has been done in EVERSE and how that's relevant. But just before we hand over to them, I wanted to say that we already have the next couple of events planned in the webinar series. On the 20th of May, we'll have a training event, which will look at research software quality assessment. This is run with our colleagues in Envry Hub Next. There's our details of that already in Indico. And then on the 11th of June, we'll take a more technical look at some of the things which determine software quality. We'll be having a talk on Julia and GPUs from one of the expert Julia developers. So we look forward to those next events, but for the moment, I think that's enough for an introduction, and we can move on to looking at the landscape of software quality and software quality indicators. So let me hand back to you, Sanja, to introduce the first speaker.
So we start with the results we have from the landscape survey. This will be presented by Jutta Schnabel. She is from the Friedrich Alexander University in Germany and is, other than that, strongly from neutrino physics, working on the KM3net collaboration. You might have heard they had a recent result on a very, very high energetic neutrino, which was actually one of the earliest results for it, and such one is quite a big thing. Other than that, so her part in KM3net is especially on data sharing, on other all things open science, and she's also working to implement all these open science and models, large language models, into neutrinos. And for now, also for the general structure, so we'll have first Jutta's talk and then Daniel's, who will present quickly before he starts to talk. So we have first this talk. If there are any immediately pressing questions, you can already ask them. Other than that, we have a dedicated slot for you later where you can ask questions. So for now, and the last thing maybe before I start, this meeting is under the code of conduct of EVERSE, which you can find online if you're interested. So we would ask for a respectful atmosphere here. And with this, I'm handing over to Jutta.
Yeah, Sanja, thanks a lot. And Graham and Sanja, thanks a lot for the introduction. Let me share my screen. This time, hopefully without Zoom crashing. So I hope you can see the full slides now. Yes.
Yeah.
Okay, good. Okay, then let's go ahead. So yeah, coming from an astrophysics background and in the daily work of what we are doing, entering a project like EVERSE, where it's about a lot of different ways to approach scientific software and scientific software development, we started out in the work package to actually to try to understand where we actually are when we talk about software quality and developing tools for the researchers for better software quality. So just to give you an overview what Work Package 2 is actually about, in Work Package 2, we are basically responsible for the knowledge part of the EVERSE project, meaning that especially with these different kinds of practices, with these different kinds of approaches that we probably have throughout the different EOSC clusters, from social sciences up to different parts of natural sciences. The first thing is that we actually try to collect and consolidate the different practices that we have in the different clusters, and then from this deduce where we how we can deliver the tools for the researchers to improve their software quality. So the design and implementation and delivery of this is targeted in the RSQ kit, to which also Daniel will give a closer road towards. And last but not least, to go really towards the tools implementation, we try to deduce from what we have learned the existing indicators on software quality and bring them into play for the EVERSE project in general. So, of course, if you're starting out, the question is actually who's doing what and how is actually software quality approached. So the first deliverable in this work package was to create an overview, to create a survey. This idea was not that we basically answer all the questions right ahead and give the full list of indicators and the full list of tools, but to basically understand the rough differences and the rough commonalities between the different science clusters, and also identify where there are perhaps already best practices that are good to adjust, or where we have gaps and deficits when we talk about research software. So, of course, if you're a scientist, you do a survey if you want to get data. So we created that survey in order to collect the best practices that exist, but also to share the experience of people who are already aware of guidelines and tools, and also do a very first collection of these different tools. So we did not start out with this work from scratch, but we were happy to be able to build on previous work. So in the EOSC Task Force on Infrastructure for Quality Research Software and Task Force on Ensuring Software Quality, there were already quite in-depth publications available and conceptualizations that could help us in designing this survey. Because asking about what do you do about software doesn't seem to be detailed enough to actually get the information that you want. So we tried to define which were the different approaches to software and classifications also of software that we could use to differentiate a bit more the different parts of software quality. So one of the points there that we took up from this was that basically, of course, software always goes through a development life cycle. So there might be different tools and quality aspects involved in planning, from developing, maintenance, and the archiving. So through the whole life of the software. Then, of course, software can be applied on very different levels. Software can be the code that you write on your computer to do some kind of analysis. Software can be an installable package, a very big project that a lot of people have contributed to, but it could also be something in between where you try to develop a tool that is then used in the larger community. So these software levels on analysis code, prototype tools, and research software infrastructures also helped us to design the survey. And last but not least, of course, when we want to move in the end towards indicators, we already started out with trying to understand what are the dimensions in which these different kinds of quality aspects, indicators, we seem to be using some of these words interchangeably sometimes, are where they are relevant. So we try to cluster them according, for example, to technical quality, security aspects, fairness aspects, and so on. And to actually understand already if these kind of dimensions and approaches make sense to all the people in the different clusters, we had a preparatory workshop with the participants of Work Package 2 to dig deeper into these different setups. So you can find the outcomes if you like if you like sticky boards, then you can have a look at our Miro board where all these different things, outcomes from the workshop were collected. And in the workshop, we reflected at first if actually this setup would make sense. And secondly, then we already started to dig a bit deeper into the software quality dimensions that we would then ask people about, so very more specific software quality aspects, and that where we could then ask people if they do practice it, know about it, or have even ideas where we can find further guidelines and supports for that. So from this, we basically deduced our survey. We took a open platform. In this case, of course, as a European project, we took the EU survey platform, which allows to establish a very well and also data protection friendly survey. And we were able to use this to create a very, let's say, detailed survey. It was a very long one. So I think people had to really take a bit of time to go through this. But it also tried to accommodate the different perspectives and the different possibilities that the participants to the survey had. So first of all, we entered the above mentioned parts. So we had a part on software description and general guidelines and support. So reflecting these levels, for example, that we introduced before. We had a part on project management and environment, so everything that happens around creating software. And then we had the part on the technical software aspects. And these different sections could be added or to the survey, depending on how confident the participants felt about answering them. As we tried to do a landscaping, and we knew we would not have that many people in general perhaps participating, we gave the opportunity to answer this survey in two different modes. So the one mode was to say, I am here as myself, and I give all the view that I have as a, for example, developer. So this was called the single view. But then we also, as we are here with representatives from the different clusters, we also ask several people to fill the survey in a representative view, meaning assuming that they know more or less how practices are working in their different clusters, to generalize their opinion here towards the whole cluster. Of course, this can only be a very first approach here, but this is how we try to cover also a more generalistic approach to the whole thing. We had the survey open last summer, and in the end, we collected 28 responses. As I said, not that many because it was very long, but they really already gave us a good view towards different practices, approaches, and also tendencies in how software quality is applied. So most of them answered in a personal perspective, but we also had a part of them which represented their research field. And if you see on the right-hand side, the participation from the different clusters. You see also that we managed at least to secure participation from all the different clusters, and especially there where the participation is low, we more or less had also contributions from the general point of view. So, also the participants were mostly practitioners or software managers, so more on the really hands-on side as well, which gives a good insight into actually how it's really done. With these survey results, we try to make them as available as possible and as easily available as possible, meaning that they can now be found on GitHub. There are pages which display the different answers to the questions. And there's also a small, a few scripts there and notebooks where you can actually, that you can launch on MyBinder and use a GPT interface if you like, or just filter through the results of the survey by yourself. So coming quickly to a few of the results to summarize them, what did we actually find out? So on the one hand, looking at the general part, we asked at in the beginning, are you actually aware of these software levels and how important are they, and how aware are people of using software quality aspects in this work? And as you can see, of course, mostly either the personal analysis code is important for people, or the big packages, let's say, so the research software infrastructures, but quality dimensions or quality aspects are quite differently distributed between them. While, of course, for the larger packages, it is more natural, let's say, and more common to apply quality aspects. For analysis codes, this is usually not so much the case. So especially there is a certain gap in applying software quality. When going to the environment and where we actually do our software development, some gaps, especially in the financial supports, were quite often mentioned. For example, especially towards maintenance and the long-term support of software. So while you usually get better funding for the development, the long-term aspects are often missing. And also funding is not very often directed really towards quality itself. So actually to ensure software quality is not funded extremely well. And on the other hand, there is, however, good infrastructure that is very commonly also used and people are aware of. And of course, top of the list, although it's starting here too, because the first outcome was a data management plan platform, which doesn't really reflect the qualities, the practices itself. So the first important part, of course, is GitHub and GitLab, if you look towards infrastructures and common infrastructures, but then also platforms like Zenodo or Software Heritage were very well mentioned. And of course, then also more dedicated national solutions like the Netherlands eScience Center, I think, which also presents some of the participants who are, depending on that, always closer to the one institution or the other. But which also shows that we have on the national levels very good initiatives that have to come into play. Then we're looking at community practices and how to actually make a software open and collaborative. Several aspects there were mentioned and identified, like co-creation with stakeholders, which is an interesting aspect because I think this is something that in research does not always really happen because softwares very often are generated from the very specific research context. And then, of course, providing training and also open science training to make people understand the necessities was mentioned as very important community practices. If we look towards incentives, so why actually people want to apply good quality to their code, might be interesting to point out that, of course, beyond receiving funding, which has a high score, actually the point of reusability and interoperability have a very high score, while, let's say, the very strict rules application, so for example, contractual requirements, or also really following regulations, is not really always the incentive. So this suggests that, let's say, the more idealistic, or of course also substantial reasons are very important when talking about why people apply software quality. When we go towards security and ethics, as you can see here, it seems to be that, especially for research software, of course, accuracy, transparency, and being able to understand what the software does has a very high importance. So especially reliability and accuracy are important for research software. And on the other hand, when you talk about ethical aspects, especially openness and transparency, and of course also provenance, seem to be rated very highly. So, which I think reflects well that in research, it's mostly really about understanding what it does, and being able to reconstruct what's been done. In testing and reliability, let me try to speed up a bit. Of course, there, as mentioned before, as Git seems to be a very widely used solution, this also shows that Git can be a basis for, let's say, a starting point for further developments in EVERSE, because the practices around there are very well known and established, especially towards making software reliable. And on the usability side, also speaking about why research, specific aspects of research software, you can also see that, let's say, what scores lowest is actually optimizing usability of the GUI or the API. So we end up with software that is actually made for people who know about software. And perhaps therefore, the assumption is often that you can expect the user to understand more easily, even without the nice usability features, what they have to do. If that is true, I don't know. And last but not least, about documentation, also here, the very specific research aspect, we are really good at issuing scientific publications about our software, but perhaps not that good always to make general documentation. So as summary, first of all, let me remind you, so this survey is not representative. It was made for landscaping, not for the statistical purposes. We tried to surpass this by introducing representative views and also confidence questions, but this can only be seen as, these results can only be seen as a trend. And in the what we could extract in the end is really, that was, I didn't show this, but a very long list of very good references, so that we can also use further in the project. And we were able to identify some common practices on the one hand and gaps on the other hand. So if you want to use and further peruse these results, you can find them on GitLab, on GitHub in this case. Yes, so and we were planning to take this actually really as a first step to also dig deeper into some of the mentioned aspects in the future. So thanks for the attention. And yes, so if you have any questions now, especially on the content, I'm happy to answer. And the discussion we would postpone to later.
Great. Thanks a lot, Jutta, for the overview on your landscaping results. As said, if you have any immediate questions, especially on content, we can give a bit of time now. And other than that, we have more than enough time also later. Maybe in the meantime, in case there will be a question incoming, I think, Daniel, you can start to share, and also let me quickly introduce Daniel to you. So in EVERSE, especially, Daniel is one of our work package leader, co-leading work package 5, which is on recognition and training. And he is based at the Universidad Politécnica de Madrid in the ontology engineering group, where he is leader of a team, and this team is focusing especially on how to increase open science and good practices to all kinds of scientific domains with AI techniques. And his other research activities are then focusing on e-science and the semantic web and how to better understand research software and scientific workflows. In between, there's actually one question. So I would maybe say, let's quickly answer this one. So how many people from which countries have answered the survey? Jutta, do you know?
So we have 28 overall participants. We didn't ask for nationality. We asked, I think, for the institutes. So I can't really say how many there were from the different countries. But so it was really mostly focused on EVERSE participants. So I think I don't recall having any participants outside EVERSE contributors.
Thank you. Then in this case, I will hand over to Daniel on the role of indicators and dimensions in research software in the framework of EVERSE.
Thank you. Thank you, Sanjay. And even though I'm a co-lead of the work package 5 today, I'm not feeling that role. So I'm gonna be talking about a little bit about the framework that we have for representing software quality. So for those who know me, and thank you, Sanjay, so much for the introduction. My background is heavy on knowledge representation, so I'm always very insisting on having proper definitions on whatever that we are pushing forward. No, and I think that presentation is going to highlight this, because I think it's very important when trying to define a common framework for research software quality. So I wanted to give some context for the people who are maybe not from the project into what is exactly that we are doing and why you should care about that, right? I was going over the initial proposal, and I really like that the first objective really highlights why what is it that the project mainly does. For me, well, apart from the community, which is also very important, is to have a structure, right, for evaluating, verifying, and improving the quality of research software and code. So basically introducing a framework for assessing software quality and software source code quality. However, there is already a lot of work, no? And the excellent work presented by Jutta and Kai already highlight some of the practices, but there are also standards, right? The ISO standards on software quality. There was a task force for more than 1 year on the European Open Science Cloud on infrastructures for quality research software. There has been biohackathons for finding software quality indicators that have found hundreds of different software quality indicators. There have been also best practices in different communities for research software in general, so, best software engineering practices like the carpentries, the chaos community, the community health analytics in open source software, the Open SSF best practice batch program, and many code quality tools that will help you increase the many aspects of your code, right? Either conforming to best practices and formatting, automated testing, and so on. So the thing is that we do not want to reinvent the wheel. So we have gone over many of those approaches, part through the surveys that Jutta introduced, part through other surveys, and browsing of the state of the art to make sure that these practices were already being considered in the project. And what we have come up as a framework for research software quality is one that extends existing standards and that is quite simple. But simplicity sometimes takes a long time to actually agree on. And what we have tried to do is to make sure that at least all the definitions that we use within the project are well and properly defined, right? And this is something I always I always spend quite a bit of time on. So from a top-down view, I'm gonna be telling you how the different aspects of research, how we have basically organized the different aspects of research quality. The one that is maybe the most general one is what we call a research quality dimension, which borrowing a little bit from the definition of the W3C standard for data quality, we define dimensions as criteria that are relevant for assessing quality. It's a very general definition, right? We add that a definition, in order to have a dimension, you must have one or multiple indicators to measure it, and I'll be going to an indicator next. So an example of a dimension, as I said, some people call it aspects or characteristics. An example of a dimension would be this example from the ISO 2500 on reliability, which is the degree to which a system, product, or component performs, specifies functions under specified conditions for a specified period of time. So basically, this is a very, very generic definition that will help us later group metrics or indicators under it. Then we also came up with a first set of dimensions. These are dimensions that were already defined by the ISO 2500 standard after much discussion. And we decided to extend these initial general dimensions, which are 9, with 2 additional ones, one for fairness, because we thought that fair is an important aspect of quality, and sustainability, since also we have the SSI as part of the group. Sustainability was found out to be something very, very important as part of the research software being developed. Now that we have the dimensions, the next aspect is the quality indicators, right? And what we mean by quality indicators are these specific aspects of software quality that can be measured somehow. So this is also a definition inspired by the W3C data quality vocabulary. And basically, it tells you that anything that you can measure, we consider an indicator. The indicator may be something binary, like, well, a source code repository should have a license, right? And or for example, can be something that is a continued value, like a percentage of functions that are documented in your source code, right? So these are 2 examples of 2 different indicators that do 2 different things. Note that indicators, they do not come up with any judgment, right? So we are not giving scores on how good you are or how bad you are. An indicator just measures something, and then how you interpret the indicator for now, well, we are keeping it a separate discussion. As an example also of what is not an indicator would be something a little bit more abstract, right? So, for example, one of the definitions of the FAIR principles, which is software FAIR for RS principles, which is software is described with rich metadata. I mean, if you don't tell me exactly which metadata you're looking for, I cannot measure it, right? So ideally, if I give you an indicator, you should, and you create, I don't know, the 2 different implementations, in theory, the result over a single resource should be consistent. The idea is like this. So a quality indicator is associated with a quality dimension. And then we have the research quality tools, right? The research quality tools measure 1 or more indicators, generating a set of assessment results. So we do have that the assessment reports are generated by research quality tools, and they are produced on indicators. And as I said, this is like a top-down view of what we have been generating. It's quite a simple representation, but it's quite powerful as well. And you can start doing some things that are a little bit more complex. As it often happens, sometimes with simple representations, you can represent complicated things that then turns out to be complicated representations. But at least this top-down view, I think, provides a solid framework to relate all the dimensions, indicators, tools, and assessments that we want to have as part of the project. In addition, we have spent time making sure that this representation is also compatible with the ones being produced by other projects in the European Open Science Cloud, such as OS Trails and FAIRcore for EOSC. By ensuring this, we also enable that all results are interoperable with whatever they produce in such projects. And as I said, sometimes from indicators, so these simple representations may be a little bit more complicated than it looks as a first glance. So for example, a tool may be used to calculate an indicator. And here I just put an example. How Fairies is one of the tools that we are considering as part of the project. And it has, here it's just showing 2, but it may have more indicators. One for checking whether the license is there, or another one for checking whether minimal metadata is described within a source code repository. And each of these indicators are associated with a quality dimension that is part of another more general quality dimension of fairness, right? A tool may also be associated with a dimension, because one of the things that we are doing as part of the research software quality kit is that we are gathering best practices and also pointing to tools that are useful to accomplish those best practices. So for example, in this case, the code meta generator is a tool that will help you generate code meta files, which are good for addressing some sort of fairness. And therefore we associate in the metadata of the tool that is associated with the fairness quality dimension. So we use them both for quality pipeline generation and also for browsing capabilities. This is an example of an indicator. I'm going now down into a little bit of technical detail on how does it look like in practice. We are using JSON LD, which is JSON plus a context. So each of the keys of the JSON are properly defined. And as I said, we reuse as much as possible existing vocabularies and standards. In particular, we extend the W3C data vocabulary standard, schema.org, and code meta for our different vocabularies. We chose these representations because they are heavily adopted already in the web, and they provide a very simple framework so basically we don't have to redefine these simple metadata properties that we are requiring to identify our indicators or dimensions and or software quality tools. An important aspect as well is that for the most part, we are not defining our own quality indicators. We are reviewing the indicators done in the state of the art, the ones proposed by existing tools, and we are adopting their own definitions. I think that it is not the purpose of the project to, again, define like the unique set of indicators, because many people have already worked on this. So what we are doing is reflecting the current state of the art. The problem is that there are hundreds of indicators already defined. I think the BioElixir hackathon identified more than 200 different quality indicators, and there are more. So what we are doing is we are in the process of identifying which tools are actually generating those indicators, how these indicators are defined by each of the tools, and then we are bringing some of the most relevant definitions iteratively into our catalogs, right? This is an example of how, as I said, we are doing it. We keep a repository with all the indicators that we are keeping at the moment, and they are all identified with persistent identifiers, so you can browse them in perpetuity. We are also doing, as I said, bringing an initial set of indicators and tools to start converting as pipelines with GitHub Actions. In fact, we identified so 4 different tools now that we have a reference framework to build on. And our idea in further hackathons that we are starting to do is to see how to represent the assessments of each of these tools in a consistent format, so we can later build on whatever these tools are generating. So we are documenting everything because sometimes the indicators from the tools are very varied in the documentation, and we want to have this elevated as a first-class citizen to make sure that we can build stuff with whatever the tool is generating. These are 4 examples of tools that, as I said, we are considering at the moment, but we will be including more based on the landscape analysis that has been already done by Jutta and Kai. And how are we using all this framework in the project? Well, we have 3 different branches, right? On the one hand, we have the best practices, which are described in the Research Software Quality Kit, the RSQ kit, which you can access in the links in the slide. And why are we using that over there? Because in the RSQ kit, we also consume a lot of metadata of indicators. And that metadata is well identified in following that format that I just said. We also have tools. We have a technology radar that browses which quality tools can be used for the different dimensions, and that the tools are described according to this quality representation. And finally, we are also in the process of building dashboards of assessment quality results, and those dashboards actually are linked to the indicators and dimensions that I also just mentioned. So each of these are in different repositories and websites, which are available in the slide. And with this, I think I'm almost about the time that I wanted to cover for you today. So I just present here a little bit more information in case you want to, you feel curious and want to see what are the current indicators that are defined. Again, this is work in progress. What is the current metadata schema that we're following for the tools, indicators, and dimensions, and how they are related with each other. And everything is in GitHub open. So if you want to have a look, and most important, if you have any concerns, and you think that we may be missing something that is critical, please open an issue. And so that's my last slide. Thank you very much. I don't know if there are questions.
Thank you, Daniel, for the presentation. So yes, please do engage with us. We're very happy to always see new ideas coming up. We now open the floor to questions and discussions, to all kinds of things. To, of course, if you also have questions about EVERSE, feel free to, but especially to Daniel and Jutta and the work that has been done so far. You can, to ask a question, you can either write directly into the chat to all of us, or you can also raise your hand and speak directly.
Yeah, in the meantime, while we wait for a question, because I know that the work that I presented is a little bit more conceptual at times, I wanted to ask maybe a question for Sanjay. So I know that when you guys were designing the survey, you wanted to open up with a broader community, but I see that most of the participation is within the project. Will you do some second attempt to gather, I don't know, some sort of international adoption of the survey?
You mean the landscape survey?
Yes.
That will go to Jutta. I wasn't involved in the landscape survey.
Apologies, I meant Jutta, not
Well, so we will. So first of all, the survey is actually still open, and I think linked at some places. But of course, this is nothing that at the moment we are following up and asking for more participation, because I think also that the outcome of the survey is for the purpose that it had, it served that quite okay, even with only these 28 participants. What we want to do next is to dig deeper into specific aspects, also with in exchange with the other work packages, so that we can kind of push along the work and design then follow-up surveys that are more targeted towards certain aspects. And then, of course, it makes a lot of sense to try to engage in a broader sense than only the EVERSE participants.
Now we have a rather long question from, I hope I'm going to say the name correctly, I'm sorry if not, Juan Costa, but if you want, you can also unmute yourself. You can speak directly and maybe repeat the question if you want, but I can also read it out loud. Yeah, then let me read it. So if you're here, yeah, please speak up.
Can you hear me? Sorry.
Yes.
Yes. My question is about, for example, if we have a specific research software that was already evaluated by others initiatives, would it be possible to reuse the indicators that was already assessed by others to avoid redoing again the same assessment? For example, a specific example is the Journal of Open Source Software, the JOSS journal. For example, if the reviewers already accepted a software in this journal, it means the software was already assessed for some quality dimensions. Then I just wonder if would it be possible to rely on those assessments made by others, just to avoid fragmentation of assessment in many different projects that we have nowadays evaluating research software quality.
Thank you. I think this is a very, very, very good question. And at least, well, and now I'm gonna give you my personal view, right? Because I cannot speak for all the people that are in the project. But what I think, well, first of all, is that the type of assessments that we are trying to do, most of the indicators are, if possible, being reused from what other people on other tools have done, right? We are collecting some of these, and what we are focusing is on the automation part. So we are, as in this case, the JOSS ones would be orthogonal to the ones, because these are quality dimensions that would have been assessed by different reviewers. And in my experience in JOSS, they focus more on whether they could reuse the software, right? Or whether it follows certain practices, but it's not necessarily that there is a given set of properly defined dimensions. It's a little bit more subjective in those cases. So I think those are very, very valuable quality assessments, but I would consider them orthogonal to part of the work that we are trying to propose here, which are quality pipelines, bringing tools, and try to put all those together. But as to whether they can complement what we are doing, absolutely. Does that answer your question? All right. I see one person with the so I see one question in the chat and then Thomas. So I'm gonna go quickly over first the one in the chat before going over the hand raise, Thomas. So what would be the best ways to map or discover quality pipelines used across science clusters? I think that part of what we want to do with all this structuring of knowledge is precisely support this. I do not have an answer right now, but I hope that the best way is through possibly going into the RSQ kit and asking, hey, what is it that you would like to know about what are the quality pipelines used in a cluster? And then you would be able to have a link through there. I don't know if we are going to be supporting additional means, but I hope that we also provide this. I don't know if Kai or Jutta, you have a better answer for this at the moment.
Well, I don't know if it's better, but I can add to this that in work package 3, where it's about the implementation of the pipelines, we try to approach this by, again, doing a workshop where from the different clusters, people presented their versions of pipelines. So again, of course, you can't do a full survey of everything that is there, but we try to get from this what the common practices are between the different clusters from the presentations that were made there, and start now the prototyping for the implementation in EVERSE from the outcomes of this workshop as well. So again, a more hands-on, let's see what you're doing and let's try to get a common approach to this for the implementation itself.
Great. Thank you. I think we had a raised hand by Tamas Gal. If you're still having your question,
Oh, yeah,
Yes.
thanks. That's obsolete right now. That's fine.
Okay, good. Then we have another question from Christopher Erdmann. Do you want to say it out loud, or should I? Or I can also just read it. Right. So the question would be, are you taking into account the work in industry and government to assess quality and compliance with software bill of materials with SBOMs?
As far as I know, I'm not sure if some of the tools that we are considering are taking into account the SBOM, the bill of materials. I do not know. I will have to double check. There are many indicators. We are looking mostly also on things that are open source, and I know that we are also looking into some of the metrics that are defined, I don't know, for example, in industry in terms of Microsoft and so on, but I cannot tell you at the moment if we are considering some of these. Right now, at least the part that I was introducing a little bit more is the framework for accommodating the definition and structuring of new indicators and quality dimensions. I am sure that with this, the good thing is that we can actually, if you want us to include something, it is possible, because we are providing the means to collecting and providing a framework to actually add more tools, add more stuff, right? So that's the only answer I can tell you at the moment, but we'll probably look. If you have some pointers, please put them in the chat and we'll definitely have a look. Also, for the people that are saying the JOS indicators, if there is like a page where they define like what are the quality dimensions that they require in the reviews, or the definitions of the quality indicators, then it would be great, because we can also reference to those.
Right. Thanks for the hint with FOSDEM. As Elena mentioned, we have, like, I can't say if it's like specifically for your question here, but we do try to get in touch with industry, which is a subtask of work package 1, but this is still in the making. We have another hand up by Professor Andrew Dubber. Please.
Hello, sorry, I'm a bit of an interloper here. I'm from the Industry Commons Foundation. I'm working on a project called Lumen, which is another European project that brings together open science and creates software platforms and LLMs for SSH, mathematics, molecular dynamics, and Earth systems. And I'm also on a project called Graphia, which is about knowledge graphs for SSH. Daniel, you might be interested in that one. But as part of Lumen, I'm producing a podcast called Inside EOSC, and I kind of feel like maybe there's an episode here to be made about how EVERSE is developing software to support scientific research, and I'd be really interested in talking to both you, Daniel, and Jutta about maybe doing an episode that's specifically dedicated to that. But the other thing that springs to mind, particularly when talking about software quality within scientific research, is you talked about FAIR, which obviously is very important. About 5 years ago, we did an EOSC study called Expanding EOSC, and as part of that, we came up with a sort of a counterpart to FAIR, which is JUST. Obviously, FAIR and JUST, both acronyms, obviously. JUST being judicious, unbiased, safe, and transparent, which is about the behaviors of the data users, data managers, data researchers, and not about the technical capabilities of or the technical characteristics of the software of the technology. And the way that it sort of plays out is through annotation. So we're not talking about the data, we're not talking about the metadata, but we're talking about the annotation that is associated with the data at the data set level, which is a sort of a living document. Now, we've brought that just data practice or just data annotation principle into these projects, and it feels like that's something that could be of use more broadly. I mean, it was adopted by EOSC, it was incorporated in the SRIA, it's in all the documentation of this is how EOSC works. But we still have to sort of wave flags about it and go, yes, fair, but also just. And this is something that we're still developing. But I guess my question is, beyond these sort of podcast interviews that I'm quite keen on doing, how can we do sort of effective knowledge exchange across these projects? So these things that we're developing and sort of advancing in one project can be incorporated into something like EVERSE.
I mean, I can comment on the podcast. We've been in touch, so it's great to be working, and thanks for sparking the idea.
Sure.
I'm not sure if anyone else from the panel wants to answer to this in addition.
Well, I would say that thanks to these kinds of events, at least we can be aware of what everyone else is doing. I'll be happy to reuse the things that you guys have developed and incorporate them into EVERSE. I mean, yeah, we should have a conversation possibly.
Sure. I mean, Daniel, are you the person? We have a separate meeting after this, and that's the end of the conversation, or are there people that I'm not aware of yet that I should be having very important discussions with?
Well, possibly. I mean, I'm our work package lead, but possibly we need to have the persons who are well, Fotis and Salva, no, who are the coordinators of the project, and many of the ones who are in this conversation. So in this seminar, at least. So I think with the ones that are here, we can follow up and see who to involve to make this happen, I think.
Fantastic. Okay, well, Sanya, you have my email address. Do you want to
yes,
put us in touch? Yeah, please.
Yes, we'll do. And I will definitely loop in our project coordinators too.
Wow.
Maybe just before we close, because there was a question, Andrew, would you have a link to the just you mentioned?
I see that in the yeah, yes, I'll tell you what, I'll send you a link to the Just white paper. That's probably the easiest way to do that. So there we go.
Then looking at the hour, we filled the webinar exactly to the minute. Thanks a lot to our speakers for the presentations, and also thanks for the discussions and the input we saw about links and ideas. It was really, really great. We will have, as we said, so there will be a next webinar that's more based on training in about a month, on the 20th of May. This will be a bit longer, so we can also have an interactive part on this. If you want to rewatch this webinar again, it will be on YouTube. So we recorded this. We will just cut the ends and the beginning, and then it will be on our YouTube channel, which you can find in the chat just now. And you can also join us in the network or subscribe to our newsletter. You can find all the information on our webpage. But we are happy to see you, and we're many thanks for coming here. And with this, I'm wishing you a wonderful day and see you soon.